Hey guys, welcome to our next set of notes. We already reviewed a little bit of adding and subtracting fractions, which we're practiced in class, and now we're going to launch into multiplying with fractions. Okay, now when I say fractions, I mean any kind of number that contains a fraction, even a mixed number. So we're going to do lessons, that's my old way of doing it. We're doing 4.2, 4.3, 4.4, and we're actually going to throw in a little bit of 4.1 just to be honest with you. So we're going to be multiplying with fractions. So one of the things I want to talk to you a little bit about is how to estimate fractions. Sorry, I'm making a lot of noise, aren't I? So when we estimate fractions, we're trying to get a ballpark idea. And so I'm going to just show you one particular type of estimation that shows up, and then we'll launch into reviewing how to multiply with fractions. So we're going to estimate by rounding fractions to 0, 1/2, or 1. Okay? Now, this is pretty cool, and I never thought about this before, but I saw some videos today, and this is what a teacher talked about. So every time you want to round, you gotta think of a hill. At the bottom of the hill would be numbers like 0 and 1. So numbers like you would see on a number line. Now at the bump of the hill is going to be halfway between those two numbers, which in terms of fractions would be 1/2. And then what you're going to do is you're going to look at your number and you're going to estimate where would that fraction fall and what would be happening. So basically we'll have something like 7/9. Here, I'm going to put it underneath here. Oops, let's put it underneath. Let's do a nice 7/9. Now, half of 9 would be about 4.5. So if I had to make a mark, I'd say about here would be 7/9. So what you think about is if you put a ball here at that 7/9, would it roll towards the 1/2 or would it roll towards the 1? And you can say it's already on the downward, so for sure it would be close to 1. Okay, let's try another one. So they're all going to be the same in terms of we're going to have a 0, we're going to have a 1, and up at the top is going to be a 1/2. All right, so this time let's try 1/3. Okay, so 1/3 would be somewhere around here. Okay, somewhere around 1/3. Now, if you think about it, you're like, gosh, it looks like it's going to slide backwards, but it is actually closer to the 1/2. So if you've got it rolling and it's got that momentum going, it's going to go all the way up to the 1/2. So we would say that this is approximately equal. So we'll do the little orange guy again. He's going to go this direction. That would be approximately equal to 1/2. So 1/3 is a little bit closer to 1/2 than it is to 0. Okay? And we get one more. Boop. So here's 1, 0, 1, and here's the 1/2. And then what if we wanted to round, let's see, 1/8? So if I had to think about where 1/8 would be, wow, it's going to be not in a pretty spot. It's going to be about here. So at this point, there's really no trajectory going upwards, right? It's going to definitely roll back down. So we would say that this is approximately equal to 0. Okay, now, the reason why we use this is because you want to give yourself a kind of an idea of, oh, let me draw my little arrow this way. You want to get an idea of when you're multiplying, is your answer going to be, close to 1, close to half, close to 0? And again, 0, I'm going to put it over here. If you get an answer that's approximately 0, that just tells you it's a very small number. Okay? So I just wanted to share that with you because that's going to come on our, we're going to be practicing that today in class. Okay? All right, so let's talk, and I'm going to go to a new screen because I want to go through all the rules of multiplying. So to multiply, with fractions. Now, when I say with fractions, I am also referring to mixed numbers. Okay? Now, I can already say that an improper fraction is a fraction, but a mixed number is unique, that it has a whole number part and then a fraction part. So this is going to apply to any kind of mixed number, whole number, improper fraction, regular fraction, and multiplication. So, number 1. And I'm going to yell at you a little bit. You must have 2 fractions. Now, we can do more than 2 fractions, but you have to have a minimum of 2 fractions, so there's no math that can take place. Okay? But what I'm talking about is if I have a whole number, I need to make it a fraction. If I have a mixed number, I need to make it a fraction. Okay, so what if you have a whole number? How do we take a whole number and make it a fraction? And it's super simple. What's the only number we can put in a denominator that's not going to change the numerator number? And the answer is 1. So we're going to give it a denominator of 1. So, in other words, 32 is going to become 32 over 1. Okay, not too shabby. All right, what if we have a mixed number? Well, remember on our other 7 notes, we showed you how to convert a mixed number to an improper fraction. And so that's our job, is to convert a mixed number. We're going to convert to an improper fraction. Okay, so on that one, I'm going to take a little bit more room to remind ourselves of the process. So we would have something like 4 2/3. Okay, so remember what the process is. We're going to start and we're going to multiply the denominator times the whole number. So I'm going to write that over here. Multiply denominator by whole number. Okay, so notice I'm keeping everything orange in this part. Then we're going to add the numerator. So add the numerator to the product. Remember, and as we write these steps, is you got to do the first step before you can get to the second step. Okay? And then to create a fraction, and in this fraction, the denominator stays the same. Okay, and again, these first two steps are how we create the new numerator. So we go ahead and we do our math, and we're going to get 3 times 4 is 12, and then we just write out the rest of it. Plus 2 divided by 3. And then we simplify that, and we get 14 thirds. Okay? So that's the process. Okay? Now, I am going to make a little statement over here. You do not need common denominators before multiplying. Okay, all you're going to do is create yourself a ton of grief if you do that. Don't do it. Trust me on this one. Okay? All right, what's our second step? We're going to try to what I call pre-reduce common factors from any numerator to any denominator. So even if, let's say, you're multiplying 3 fractions together, if you have a numerator that can cancel with a denominator of the third fraction over, that's fine. Okay, we're going to look for common denominators. Okay, so this is called, sometimes known as, cross canceling. So again, all it is you're going to divide out common factors. Okay, so that's going to happen when we work through this process. And again, any numerator to any denominator. Once you've done that, and I'm going to tell you that if you just choose not to do that step, first thing, that's okay, but you're going to have to remember always at the end to do it. Okay, so at this point, I'm going to multiply straight across. So we're going to multiply numerator times numerator. And denominator times denominator. Looks like my fraction bar needs to be a little bit longer. There we go. Okay. And then last but not least, I mentioned that just a minute ago, we are going to simplify. So that means simplify, which is another way to say reduce. Final answer if necessary. So I always get asked this question, well, do I have to do that? The answer is yes. Simple, yes. And if you don't, you're going to lose credit because no fraction answer is final until it's reduced to lowest terms. Now, here's what I mean by this. So listen carefully. Converting to a mixed number is not reducing. Okay? Now, will you ever have to take an improper fraction answer and convert it to a mixed number? And the answer is yes. When would that be? In a word problem. So, for example, if I went to the butcher and I wanted to buy some shrimp, I love shrimp, and I'd say, you know what, I'd like 5/2 pounds of shrimp. Butcher looked at me like, what's your problem? 5/2 pounds? Get out of here. I'm not going to serve you. Nobody talks in improper fractions. We talk in mixed numbers. If I said, oh, I'm sorry, can I have 2.5 pounds of shrimp? Why didn't you say so in the first place? And in your head, you're going, well, I kind of did. But that would be sarcastic, and they would not serve you, okay? So converting to a mixed number is not reducing. Now I'm going to clean up that not, because it looks like hot, doesn't it? Let's try that again. So you do not need to convert to a mixed number unless it's a word problem. If it's just normal number crunching, you can leave it improper. But I'm going to give you a choice. Okay? All right, so let's do a couple of examples, and then we will be done for today. So our directions are going to ask us to multiply. So I'm going to give you 3 different problems, and there's going to be slightly different problem each time. So we're going to have 3/8 times 10. So we have 3/8 times a whole number. So a fraction times a whole number. So we keep the fraction. I'm going to change that multiplication symbol to a dot just so you start getting used to that. And we're going to create a fraction out of that whole number by just giving him a denominator of 1. Now, I want to show you what I mean by pre-reducing. I'm going to look any numerator to any denominator to see if there is a factor that they share in common. So let's see, 3 and 1, no. 3 and 8, no. 10 and 1, no. 10 and 8, oops, they're both even. So I'm going to divide a 2 out of each of those. 8 divided by 2 is 4. 10 divided by 2 is 5. Okay, now I multiply straight across. 3 times 5, I'm going to show it to you like this. 4 times 1, that's where we're at right now. So I get 3 times 5 is 15. 4 times 1 is 4. Now I'm going to put a star here. Some people may need to show that step. Some people may not need to show that step. So I'm okay if you go from the 3/8 times 10 over 1, and then with the reducing going on, and because basically that third step is what your brain is doing, okay? Now, I check to see if 15 and 4 have any common factors, and the answer is they don't. Okay, so I can stop right here and say, yep, I'm done. But let's say you said, yeah, it's a word problem. I'm going to need to convert this to a mixed number. So this is all you do. You're going to divide the 15 by the 4. So the denominator is down. Think about it. Denominator starts with D. Down starts with D. Divisor, okay? So they're all down, denominator, divisor. Down and out, that's what I like to remember. Down and out. The 4 is going to be down, and then it's going to go out. It's going to be on the outside of that problem. So how many times does 4 go into 15? Well, 4 times 4, oof, that's 16 too much. So it can only go in 3 times. So 4 times 3 is 12. When I subtract, I get a difference of 3, which is fantastic. That's smaller than 4, so I'm done. So what do I do now? Well, I take that guy, and he is going to become the numerator of the remainder. So I have 3, and then the divisor is going to be here. So the other choice for this answer would be 3 and 3/4. So I don't care which one you give me, both of those are okay. But here's the deal. If it wasn't a word problem, I would have already been done 2 steps ago. All right, let's do a fraction times a fraction. Okay, so let's see if I can simplify anything. 3 can't go into 4, 5 can't go into 6. 3 can go into 6. Ooh, 3 can go into 6, so let's go there. So I'm going to do this on the next row so you can see what it looks like. So 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, now let me look. The only other direction would be the 4 and the 5. Next door neighbor, guys, no, you can't simplify them. So this is where I'm at in my problem. 1 times 5 over 4 times 2. So I multiply 1 times 5. 4 times 2 is 8. I can't simplify, so I am done. It's not improper, so there's no other way to write this answer. Now, let me just show you for just a moment an alternative to this problem. Let's say that you did not want to try to pre-reduce like I like to. So you just multiply straight across. You just skipped right to that multiply straight across. And we get 3 times 5 is 15. 4 times 6 is 24. Excuse me. Now I got to figure out what do these two guys have in common. And it's a little bit harder to see that these two have a 3 in common. Because 3s are a little bit stinky. 3s, even though they're an odd number, they can go evenly into an even number. How weird is that? As well as going evenly into an odd number. So it's a little harder to see when I have larger numbers. So 15 divided by 3 is 5. 24 divided by 3 is 8. And I get the same answer. So that's an alternative, but I'm going to tell you, people that wait to the end often forget to even try to reduce. All right, so now I'm going to give you the worst case scenario. What if we have 2 mixed numbers? So we're going to have to do more work. Okay, so remember how this works. We're going to multiply 5 times 2 is 10, and then we're going to add 4 to it. So 5 times 2 is 10, and 10 plus 4 is 14. So the first fraction is going to be 14/5. And then times, and then we're going to do it on the second problem. 4 times 1 is 4. And then 4 plus 3 is 7. So I get 7/4. Okay, so notice the denominators didn't change. All right, so now I'm going to look for any kind of reducing. So let's see, 4 can't go, and 5, no. 7 and 4, no. 14 and 4, oh, they're both even. Let's divide out of 2. So 14 divided by 2 is 7. 4 divided by 2 is 2. All right, so now what I'm left with is 7 times 7 over 5 times 2. So 7 times 7 is 49. 5 times 2 is 10. Now, there aren't any factors of 10 and 7 that are the same, so I'm done. Now, if you wanted to convert this to a mixed number, you could, because it is an improper fraction, and you would just say, how many times can 10 go into 49? Well, I know it can go 4 times, which is 40, and I have a difference of 9. Since 9 is smaller than 10, I'm good. So remember what I do is I'm going to take that 9, and it's going to become the numerator of my fraction remainder. And then the denominator stays at 10. So my answer is 4 9/10. So that's the second option. All right, there you go. Good. I can't even speak anymore. There you go, guys. Have a good time with this. I'll talk to you later. Bye.